Hello friends, we are live again. Let me just put it here. Yeah, we are live again, and today we will finally start working in our display, actually showing things on the screen. That's awesome. That's really awesome. So yes. So uh first starting, actually I want to address another tips from SaturnoZmarte, our friend that is always giving us very good feedbacks. So he's saying that in the do RL function CPU, the rotation must make C flag and bit 0 of register. It's really as if it was. Well, I think I did that. So we did the bit 0 is the bit 0 or is the bit 7? It say, oh sorry, let me. So here SaturnoZmarte is saying that. So let me go to CPU. He's saying that the C flag should be the bit 0 instead of bit 7. So let me see here. So LA instruction Game Boy. So let's see if that is true. I also have it here. So air rotate shift. So okay, rotate and left through carry. Left. So left means get the bit 7. I think so. See, contains old bit 7 data. So let's double check that. Wow. Oh, here. L. So here. Yeah, it says that the bit 7 go to CY. Yeah. So rotate value pointed by HL left hooker. Oh, the C value enters where. Oh, thank you for the following, Dr. 8 bits. Thank you. Appreciate that. We are now trying to get our 200 followers. We just get our first goal. What was 50. Okay, so this is mean that C enters in the bit 0. Oh, now I think what it is. Let's make the C flagger. Oh, must make the C flagger enters in the bit 3. So we keep the C flagger in temporary. C flag takes move the register to beef. Ah. Okay. Thank you, Zmarte. Let's fix this again. So first of all, we need to get the C flag. So I think we have something to get the C flag. Yeah, we have. So let's do this. So let old C flag equals to self get C flag. Okay, now we have the C flag. Then we get this here as a boolean. We set it to the new. We move it 1, but before doing that, we do it. Now it should be a mutable. Now we need to do this new register equals to new register so it will be something like I think we need just to get this. This music is not good. Yeah, we need to get this. So we now need to get this old C flag into. So we do first we do this. One, two, three, four. So then, oops. So then we remove the last. And what is return? Let's return a boolean. Then we need to put this like make an R. Okay, so this way we have our new register. We have the new register, and then we need to put the new register into. I mean, we need to put the C flag. So we have the C. So we keep the value. Yeah, we keep it here. We make the C flags take the value of bit 7. Yeah, we make it here. Move the register, we move it here, and bit 0 the value of the temporary. Yes, so that is what I'm trying to work now. So how to make this? Now I think it's just or new register. So see. I think this it's easier than I thought, than I think. Let's do this. It is an if C flag is set, as it will be in the latest one, it always means 1. So new register value plus 1. Otherwise it will be 0 already because we put it 0 there. So we are good now. Okay. So let's see if this is still running. Cargo run. Yeah, it's running and is still in the loop. So that was not the reason of that making run. Okay, so then the next tip from SaturnoZmarte is okay. So the next tip is in the execution of the inhl instruction. That is what must be increased. Not. Oh yeah, we found that yesterday actually. So inc. Yeah, but we didn't implement yet inc HL. I think so. Let's see. I think we didn't. There is no inc HL. So there are only inc. Yeah. Yeah. Yesterday I thought the same. But this inc is the other way around. So this is increment of the HL itself, not the value in the memory. So yeah, so this is okay. In the execution of the instruction LD ADA, you should put self A and should be okay. Let me see. LD AD LD A. Okay. Oh yeah. Thank you for that. Yeah. I put the contents of this. Great. We are still getting the same place, I think so. Anyway, in the PPU you put, okay, so let's see. I think this is okay. So let's see. Yeah. So what I did here, Saturno, is because when it gets to 144, the mode clock should be turned back to the let me go here, documentation, display, and go to here. I think it is mode. No? Here. So here we have one thing here. This this sequence will be repeated So let me check here. So if the mode clock is under 456 and the self mode is still not 1, so if the self mode is 1, I need to do other stuff. But if that is not 1 yet, I need to add li and write the li back. Then if the li is if the li is under 144, I need to change it back to 0. So this, when this happen on h blank. Okay, this happen. So let me. So this happened in the h blank, in this part. So I need to set the mode clock to 0 because I'm here. Then I go to 0 and okay. Then back. This is the mode clock because I need to reset and start counting to 456. If the self clock is above, that's above, then I will continue counting till here. Then it gets here and the mode will be 1. So it is only allowed to go to self mode 1 when the li is up greater than 144. Because otherwise I will set the clock to 0 and it will never get there. So hey Eva, how are you doing? Thank you to be back. It's good to see you back here. Good. Very good. Oh, today I got my Game Boy Advanced working. I bought this used from eBay. And I bought this. Let me turn it off. I bought this Pikachu stuff here. This is a very, homebrew, as they said. Like somebody did this game. This is not an actual Pokemon stuff. This is like Mario Land. I don't know if that is possible to see. It's like Mario Land with Pikachu. You seen there? So it's exactly like the first Mario with Pikachus. That's fun. So yeah, we are actually not building emulator of this device, but our emulator will be able to run this game. Because this game is for Game Boy. It's compatible with the Game Boy, the Game Boy that we are trying to emulate. Can you make an iOS emulator? No, I mean that you already have an iOS emulator inside. If you have a Mac, if you have a Mac OS, you already have that inside your Xcode. If you open your Xcode, it will ask you to install an iOS emulator. Then you are able to run. Oh, yeah. You need to actually. You don't need to have an. You need to have a MacBook or iMac or some device from Apple. Otherwise, you're not able to run any kind of iOS emulator. Oh, that I didn't know that it's possible to run iOS Android on Switch. That's new for me. I didn't know that. I don't have Switch. I have a nephew that has a Switch. That's a pretty good device. Actually, all games from Nintendo are good. But I prefer Mega Drive, the Genesis from Sega. That's my preferred video game ever. Because I grow up with that. Maybe in the future I'll build an emulator of that. So, get back to explaining that to SaturnoZmarte. So, actually here we are doing this because we need to reset the li only when it gets 154. Because let me check here, 150. Yeah, so our entire frame is 154 scan lines. It's not only 144. So besides the screen has only 144, the li counter goes to 154 because of the v blank period, because the time that it's get to there. Okay, so all those SaturnoZmarte question was addressed. Oh, there is this Artur Rodriguez that said that you should really get into the habit of putting. Yeah, I know that. I think I will put the clip. There is an a link, because you know, if you made some mistake, the Rust compiler will not allow you to compile your code. But sometimes you actually do not make an error, but you make something that is not good for performance, is not good for so it's not in the right style. It's not very I mean, so this kind of fixes. So this kind of fixes, it's not made it by compile, but this clip thing is able to help you with that. So now I can do like this. I think I already installed this, so I can do cargo clip. So cargo clip. Sorry. It says nothing. Oh, I think I need to do this. What's that? Okay, so Rustop update. Okay, I'm already running Rustop component add clip. I'm running cargo clip. I think my cargo run is already doing the clips. Let's see. Yeah, here is something. So this CB is not used. Variable does not need to be mutable. Here, yeah. Getting back to the comment, yeah, it's already saying to me to remove this mutable. So let's go to CPU. So yeah, it should not be mutable. The MMU, the main here should not be mutable also. So here here. It should not be mutable, and I can call it to be better. And this is never used, but okay, I want to be there. This is not used as well. Okay, so let me. So why that is not used in PPU? Oh, that's not used because we removed the buffer, but let me put it there. So let me see if I do cargo run. Yeah, now it is complaining for so any used result that must be used. Oh, this is here. So here I think I can put like this. Sorry, like this, or do a run unwrap. Yeah. This way I'm using. Actually, that's not the best way of doing that, but yeah. So if you see now, no messages are there. Okay. So yeah, we addressed this. So now that we are addressed our commenters and we are good to go, let's get back to our most fun part, which is which is build the display. So for that, as I said, I will use this minifb, which is a cross-platform window and from buffer. Yeah. So let's do this. I need to do let's do this. I need to put that in my cargo. Yeah. So I don't know if everybody is aware, but for installing a new package in Rust, you just add that works like package.json, like the requirements.txt from Python. And cargo is like pip, is like npm, yarn, or any other package management that you are used to use in other language. But I think there is no like a line like cargo install mini or fb. This not works. You should put it here and then run cargo install. Actually, it's already my IDE is already downloading the crates and so on. It should be cargo. Yeah, it's already actually not cargo install. Sorry, because when I do cargo run, it will compile. Yeah, now it's spending some time compile the dependencies. Yeah. And then run. So we are able to use our PPU, our from buffer. And now I will do this. We already have this buffer, right, inside here, which 256 by 256, and I don't know if that. Okay, I will put this first. Okay, that will be our first try. And for doing that, we should, for using this minifb, we should we have this bootstrap stuff here. Where I will put this. So I will try to do this at the beginning. So if we have oh, but that could be an issue. Yeah, because I want to. This will run every time the frame is there. I will do something here. I will do this. This is just a test. I will be doing this. So let PPU equals to this. Then I will do this. I will return PPU. Okay, and I don't think this is really needed. Yeah. So here, this is the thing that I will do. PPU dot buffer. What's the problem here? Oh, I will need to now I will need to make PPU mutable. Yeah, that's right. So PPU. Okay. So this is a simple test. Do Windows stuff in main and then just access the PPU buffer through a reference in the main loop. Yeah. Oh, then you mean copy from? I mean, make the buffer, the minifb buffer one thing, and the PPU buffer other, and then in the main keep synchronizing that. Is that what I think? Because I think what I can do is use this. So maybe what I can do is create a new struct. Create a new struct, call that like LCD, which is the physical display. That will be initialized in the main, and then every step in the PPU I will update that. Right? So let me think. Let me put it here first. So cargo run. Yeah, we have our screen here. So the screen is black, and I cannot even. Okay. So this is the screen. It's up to you. It's just that I would not do any window related stuff with PPU implementation. Yeah, you're right. I'm just putting it here because I want to initialize that and see that. And Uh, so let me do this. Let me test if this works. So I will create something called LCD. Okay. And I will do this. Pub LCD. What is LCD? LCD is just a struct called LCD, and that is a public. Which has the frame buffer. The frame buffer, this frame buffer is actually, I can call this screen. Let's call this screen, maybe. And this is like so. So this screen is okay. Now this buffer will be the buffer for the actual background. Oh, let's call this buffer for a while. I will just do this. Now I will do this implement. Okay, I will call this LCD. It will return an LCD. So, LCD, LCD. And this is just on the screen. Okay, now I can remove all the stuff here, all this crazy stuff here, make the PPU immutable again. Okay, so then we are, what's the problem here? Okay, and then I return that with a with a LCD. Okay, let's put LCD. So let me close this. So okay, let me do this. Import LCD screen. Okay. LCD screen. Okay. So now we have our LCD. While window is open, actually I don't need to do the let me see if I need to. So in the main, I will create LED. LCD. Okay, here it's also a table. Okay, let me see. Oh, if we don't keep that loop, this loop, base screen do not keep. Okay. So now we have this thing. So I will do what? I will not put that outside. I will follow. I think now. I think that's what then Matrix said. It's the best idea actually. Well, we don't need this. Okay. So let me copy this. Okay, so we can actually put this CPU instruction here, right? Because this is a loop. Let's see. Something went wrong. What's that? Oh, sorry. What the hell? What is the problem? Oh, in LCD. Okay. So I need to delete the LCD. Delete. written way. Delete. Okay, where's that? Okay. Okay, so now, okay, let's see if this will work. Okay, so now we have our display in the main loop. Okay, and this main loop is so if I do okay, so let me do this again. So if I do ask, the program finished. We have now a way to finish our emulator. Okay, so now it's okay. Now, as the matrix set, we don't need to handle PPU inside, screen inside PPU. We actually, outside, we get that and can update here, I think so. So, okay. Now we need to actually print something in the screen, right? Now, actually from the memory. Let's get back to the papers. So I was reading. So the Game Boy. Let me notice. This is a nice one as well. Okay. So here I think. Where is that dog? Oh no. Is this one? Yeah. Yeah, so actually we have one of the bits video. Let me. So here we have a place in the memory where the tiles are, where we have the tile set. Then we have another place where is the mapping for that tile set, like this. And I'm not talking about sprites yet. So let's see here, which is the palette. I think it's in the LCD. Okay, so LCDs here. So uh, the tail data is located at from 800 to 8f or 8. In the first case, the pattern. Okay. So if we are we can use the from this address from the 8 to 8FFF or from 8. Let me go back to. Yeah, so we have this or this, and this is set via LCDC. So let me just do this. Okay, oops, I need to put a comma here. Actually, what's that? So let's see how is our LCDC. Oh, I need to print that. I will print that. Okay, so we know that we are in loop here. So we are in the loop. We are checking here. So we are in this loop. So let's put. So if self receive equals to 0, 0, 0 EF, let's print, oops, let's print LN and new state. Is that? Something. Oh, here. Sorry, because I. And here I need to do this. Oh, it's not getting there now. What are we getting here? Nope. Oops, 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 oops. So A7. Oops, something is. Okay, let me do this. Something's changed. No? What is wrong here? What I am doing wrong? Let's do this. instruction. I think we are okay. We are running instructions and self. This. Okay, we are like getting on 70. Six. So if we are trying what we are trying to do here, we are trying to debug because yesterday this program was running to the end. Now today at the beginning of the stream I fixed 2 issues and I thought that it was doing the same, but somehow it's not. So I'm trying to reach just to find out where it is getting stuck. And for doing that, I'm doing okay, so we are not getting to the 76. Are we getting to? Oh, it's saying 7. Okay, let me see this. Okay, we passed to the 7. Okay. In the okay, so let's see if this loop is being done. So we are here in this loop, and why is that? We are not reaching here anymore. So it keeps in this loop forever. Forever! Oh no! I was just not waiting. So yeah, it's getting there. So let's see where it's 66. Okay, let me remove this and put this. Oh, now I know. Yeah. Actually, it's taking more time because we are showing the screen. Let's let me check if that's the case. So loop CPU. So I remove it, and I will just check if we are getting to the point that I thought that we were yesterday, which is here. So E8. Yeah, so we are actually in the same point, but as we can see, when we put this and let the it takes much more time to get there. It eventually get there, but see, it's still running. Maybe because of this, let me see. Yeah, I think that's the reason. Or not. Oh yeah. It's because we are updating the frame buffer with zeros. So we need to go for all the pixels every time, and that's making the code run. Do not perform well. Well, at least this is what it seems. Okay, so let's do this. I will make something here. I will create a pub get else, so function pub function get lcdc. Okay, and that is self, and it will return an 8-bit. Okay, and that's just self read byte 0. Okay, sorry, and I will do this is lcd enable, because this is from the memory. I can do this. I think I already did this in PPU. So I do this self get okay, so now we are able to get from the memory and check if the PPU is if the LCD is enabled. So then if self if MMU is LCD enabled, then we do this. Okay, so we only will update the screen if the LCD is enabled. Let's see if that happens. Okay. and the LCD is enabled like here. And yeah, it's still getting a lot of stuff from there. Okay. Okay, so I will still not turn this on. So let me just do an ask. Okay, so as we can see, we are with the else. Let me go back to here. So LCDC. Here. So we have the display turned on, and we are using the BG display priority. What is this? So yeah, we are using BG from 800 to this. So this is the tail map, the BG tail data, and the map that we are using is from here. Bit 3 is 0, so we are using this map. Okay, so in this case, the tiles come in unassigned. So so we are using the first case, so the numbers are unassigned numbers from 0 to 255. So this is the BG tile set, and this is the BG tile map. Okay, so I want to check that. So how I will check that? I will dump that in our dump here. So I will put, so that's this, and so instead of, so here I will do so BG tail data. BG tail data is from 8800. We are using here. So we are using, sorry. So we are using here, 2 here. Of course it will be a bunch of zeros, but I want to see that. What I want to see is BG tail map. Okay, so BG tail map, which is 98 from. Okay, so 9829. Okay, this should be actually 900, and here should be 9829B, actually C00. So why I'm putting this here? Because in Rust the range is not inclusive. Okay, so let's see what's going on here. Okay, so here is our tail data. Mostly, as we saw, as I said yesterday, because we are not using an emulate an real ROM, we will be compared here. We will be showing this. So here is our tail set, probably. Okay, and oops, this is the tail data, and this is the BG tail map, and here is the mapping. Okay, great. So now we just need to understand how this map relates to that BG. And actually we can actually display all the tile set in the screen just to see. Okay, so now it's time to check how the pixels are built, because I think this video is also good for bits. Here we are. So we have
some repetitions and everything's aligned to that, even though they did a very good job at hiding that. The ordering of the colors, if I want that for some.
Okay. So we have 2 bytes for each line in the tile, and the tile is 8 pixel per 8 pixel. 1 2 3 4 5 6 7 8. 1 2 3 4 5 6 7 8. Actually, there is an option to put 8 by 16, but let's consider 8 by 8. So okay, we have this byte, 2 bytes, but how that is organized? Okay, let me do something here. Boop. Okay, now I save this here. Pixels. Okay. So in the memory is like this. It's 256 tiles. Okay, but how? Oh, then there is a palette here. Palette. Okay, so let me read here. Graphics. So that's it. Okay, so we have the tile set and the tile map. The background map is okay. And then we have this scroll Y, scroll X. The background map is 32 per 32 tiles. Now I know. Now I got the full. So this stuff that is I can see here, and we saw yesterday that we have the 200 by 206, 256 by 256 is the background. So the background tile map have 32 per 32 tiles mapping there. So I think it has 32 per 32. So yeah, so we have this. So the tile map is composed by 1024 reference to the tile set. Yeah, because it's 32 per 32. So the tile map is the thing that forms our display, our background display. That's great. So let's see one thing here. Okay. So now how that is mapped. So each So we have two options here to go through reading the reading the tile and putting that in the reading the palette and then put that in the screen, or starting with that or starting with the tile map. I think we start with this, with the tile itself, because then we, even if we can show the tiles, the complete tile set in the screen, at least we are seeing something and we see that we are loading everything in the memory as it should be. Okay. So, okay, back in here, the Game Boy is often described. Okay. So then this is a node. I know this is the pixels. So let's also BGP. BGP is this. So this is the palette. Let me get back to here. Here I have BGP. BGP. Okay. So this is the shade of color number 0, color number 1, color number 2, and color number 3. As we can see, we are just black and white here actually. Yeah, we are black or white, because all the others are 333. So all the colors are. So for 3 colors, for the color 3, 2, and 1, we are 0, 0, 0, which is black, and for color which is black, yeah, it's just black, and for color number 0, we are blank, white, sorry. So yeah. Okay. Okay, so implementation. As stated above, each pixel in the dataset is represented by 2 bits. Bits are read by GPU. When the tiles is referenced in the map, run through the part. Okay, so I think the BG map this is the tile map. This is the tile data. So this is one row, this is another row, this is another row, this is another row, this is another row. Is that? Oh yeah, this is one row for in the tile. So each tile, yeah. So each tile in the data set is held in 16 bytes. So 1, 2, yeah. I got it. Okay, so now let's make a function in the PPU for read. So actually these functions here should not be here, should be here. And it should receive it. So we give to the PPU MMU and reference to MMU because, and this will do this. Okay, and why that? Because these stuff are related to the PPU, not to the MMU. Oops. Here we don't need to use this. What's the problem here? Oh, sorry. Yeah. Yeah, we actually need this. So here in the main, we can do this. Okay, now we need to have a function to get one line of one pixel. I'm thinking here. So pub function. What I want to do here. Oh wait. Get. So the code tile. Yeah, the code tile and receives the so MMU and receive the first tile byte. And return a vector let's say an array. So it will return a U8 16. Is this correct? Rust return array. That's correct. I think that's correct. So let's do something like, if I do oh, this is the problem. Yeah, so this is correct. So I want to get the first byte tile and return an array. Hmm. No, this is not. Wait. So I need to. It's held by 8. And why it's that? Oh yeah, it's 8 by 8 and 2 bits each. So it's 16 bytes. So let's see what he's doing here. View update tile. Update takes a value, write and run, and update the internal tile set. Oh, it's because it holds the tile set inside the GPU, which is nice. And get the base address for this tile row. Work out the tile and the row is updated. Okay. Yeah. So let's do some experiments here. Okay, so here since that we have a sequence of okay, I will do this. Get tile. So I will do this simple this. I will do MMU. So for for 0 to 16, yeah, to 16. First loop. So now we are checking how to do loop expressions. Loop range just. So here it is. Okay, for yeah, that's it. Yeah, it's so close to for I in what I will do is okay, so let table pixel sorry tile equals to 0 16. So tile I equals to okay, yeah, so red byte first tile plus I, then tile. What is this? Why this is a problem? Wait. No. Oh, sorry. This is U16, and then we don't have this problem. Okay. So now we have this. We have a way to get at. I like the new color scheme. Ah, thank you, Arc9. Huh, thank you. Yeah, this is Monokai. I think so. Yeah, I think so. Yeah, it's Monokai Pro. Uh, so now I have a way to get that tile. Okay, so oh, it's we already spent 1 hour and 40 minutes and not yet. Sorry, friend. Sorry, I'm too slow. This streaming is getting boring, right? Because I don't do this fast. So what I'm doing, what I will do now, I will just, when I get this point, instead of doing this, I will do this. So I know that BG. So let me do this. Pub function get BG tile data. And how I do that? Self return U8. I think it's 24. This is not the tile set. The tile set is one minute. Here, LCDC. So it is 100. Yeah, it's 255. So yeah. So this is the. Yeah, actually not. Wait a minute. It's 4K. Yeah. So it's okay. So how we do that? We just need to get. So let LCDC self get LCDC. So we need to get this to check which which BG tile set we are using. But for now I will hard code this. I will to do check LCDC. But for now I will hard code this, and I will do just for this, just for E0497 and as we did here. That's exactly what I say. This first, I will just hard coded this to be the 0x. Okay. So we will get this. Okay, so this is the tile set. Okay, so then just iterate over okay, yeah, that's easy. Now I will do this. When we get at the end, I will do this. For so let bg tileset equals ppu get bg tileset and pass a memo. Then I do for I in range from 0 to bg tileset len. So from the beginning to the end, a Gameboy Emulator in Rust. Yeah, that's it. That's it. Gameboy Emulator in Rust. So now we are in the fun part. We are. I mean, I thought that we showed something in the screen today, but we. I don't know if we will yet. What's that? Range is not in scope? Oh. I think I can do this. That should be a node. Yeah. So, sorry guys. So, then I will do this. We have the function to get one tile. Yeah. So let's do this. Let print tile. And this will be ppu get that tile. Yeah, that should be think I don't need to use this then. Oh yeah. But I don't know. Let me get tile and then I'll do. Okay. Actually, while y is lower than this, and I do so that not able by y. What happened? Oh, sorry. Okay, so we are showing okay. And then I panic. Just to display the tile set. Okay. So this is our tiles. So we have only one tile actually. Yeah, and this makes sense. Because we're gonna see this. You don't have that, so yeah, this makes sense. We actually will again, but I think you can give a stepping size for a range. Yeah. Oh yeah. Rust step by. That's interesting. Yeah, that's great. That's great. I will do that then. But this is just for the bug. But thank you, algorithm. Thank you a lot. Yeah, I'm still learning Rust. So Yeah, so we have this. We have only one tile. This tile should be that R. These are here. This. Because this will be black. Because we don't have an cartridge inserted. So now we need, so we are seeing the tiles. Okay, great. Now we need a way to transform this tile in actual representation, I mean an image. Well, I need to go. Oh my gosh. I would like to finish this, guys, but I have an appointment in 10 minutes, so I will not be able to get there. So let's wrap up what I did today. Yeah, we started with some fixes that Mark Saturno said to us, to me, and in the comments from YouTube. Then we put we create this we use this minifb for creating this little screen in the little window, which is presented there. And now we created some functions in the PPU for us to be able to get the tile set and the tile set from the background tile set, and display that as each tile in one line here. And we discover that our BG currently has only one tile, and it should be this tile, the R from the Nintendo logo, because remember that we don't load an actual ROM, so the boot ROM is not able to check that the ROM and the cartridge has the same logo, so it will keep looping in this part. So the only tile that will be displayed is this R. Okay, so now the next challenge is to finally, at least first of all, transform this, create a function to transform this tile in something in the screen, because I think that these 2 bytes are one line, yeah. So we need to align those bits. This is weird because the second is always 0. Well, not so weird. Well, anyway, I will do that tomorrow, the first time, the beginning of the stream. Again, maybe I will do that early in the morning tomorrow. I'm not promising nothing. So anyway, if you are not able to watch here live in the Twitch, you will be able to watch later in the YouTube if I do that. I mean, if I do this function tomorrow morning, because I'm eager to see. But I need to go now. So, folks, thanks a lot. Thank you for all that's watching live. and I will, as usual, upload this video to YouTube. So you'll be seeing that there in YouTube soon. Thank you a lot for watching. See you tomorrow.